This is part 4 of our lesson on rational exponents. In this part, we're going to do some examples that involve a combination of different exponent laws together. So it says simplify as fully as possible. When it says simplify, that means you're not going to get a single numerical answer. You're going to have something with variables, but you want to try to get it down to a single x, a single y, a single z, so that you don't have multiple terms left. So our first one, we have 32x to the power of 10 to the power of 3 over 5. Now, we learned that 3 over 5, the 3 is an exponent and the 5 is a root. But just like with negative exponents, I am not going to write anything as a root until I've exhausted all of the other exponent laws that I can use. And what I notice is that I have brackets with an exponent on the outside. So before I write anything as a root, I'm going to do the exponent law that says that you can take the exponent on the outside and multiply it into the exponents on the inside. So we're going to multiply 3/5 times 10, but it's also going to get multiplied into the exponent on the coefficient of 32. Now that 32 has a secret exponent of 1, so I'm also going to multiply that 3/5 times 1. So I'm going to get 32 to the power of 1 times 3/5, which is 3/5. And then x to the power of 10 times 3/5. So 10 is secretly 10 over 1. And when I multiply, we do numerator times numerator. So 10 times 3 is 30. And denominator times denominator, 1 times 5 is 5. All right, so now on this pass, what I'm going to do is simplify the exponents if I can. So I notice here that 30 over 5 is 6. That just gives me x to the 6. So I don't even have a fractional exponent left. But 3 over 5 does not reduce. So for the coefficient for the number in front, I am actually going to evaluate that part by writing this as the 5th root of 32 to the power of 3. So the 5th root of 32 to the power of 3. Now, the 5th root of 32, what number to the power of 5 gives me 2? If I look at my sheet, I see that it's 2 to the 5. So that's going to be 2 to the power of 3 times x to the power of 6. And 2 to the power of 3 is just 8. So my answer is 8x to the power of 6. Well, let's try that with a few more terms. So if I take a look at the next one, we have 64x to the 6, y to the 3, z to the 12 to the power of 2 over 3. So before I jump in and do any roots, I'm going to try to do the exponent laws first. So I notice brackets with the exponent, so I'm going to multiply the exponent into all the other exponents inside, including that secret 1 on the 64. So this is going to give me 64 to the 2 over 3 times x to the 6 times 2/3 is 12 over 3. Y to the 3 times 2/3, which is 6 over 3. And z to the 12 times 2/3, which is 24 over 3. Oops, can't see that. There we go. Okay, the 64 to the 2/3, I am actually going to evaluate that by saying that that is the 3rd root of 64 squared. Now, x to the 12 over 3, 12 divided by 3 is 4, so it's not even a fractional exponent anymore. 6 divided by 3 is 2, so I get y to the power of 2, and 24 divided by 3 is 8, so I get z to the power of 8. Now, the only thing left to do is to work on that coefficient. So the cube root of 64, what number cubed is 64? 4 cubed. And then that's still squared. And then I have x to the 4, y to the 2, z to the 8. Now 4 squared is 16, x to the 4, y to the 2, z to the 8. The next question, the next two questions, have a few more steps than the previous ones. So this one here, we have 10x squared y to the 9 times 15x to the 9y divided by 6x to the 3, y to the negative 2, and then all of that is to the power of positive 1/2. So before I deal with the positive 1/2, I'm going to use my exponent laws, and the rule we follow is BEDMAS for brackets, exponents, division, multiplication, addition, and subtraction. So I start with my bracket. So I'm going to start by doing everything inside this bracket. So I'm going to begin by multiplying the numerator inside the bracket. So the coefficients, 10 times 15, we just multiply those together. 10 times 15 is 150. The rule for multiplying is that you copy the base and add the exponents. So x to the 10 times x to the 9, I add 10 and 9 to get x to the 19. Y to the 9 times y, this is a secret y to the 1. So 9 plus 1 gives me y to the 10. And then that's still divided by 6, x to the 3, y to the negative 2, all to the 1/2. On the next pass, we're going to deal with the division that's still inside that bracket. So 150 divided by 6 is 25. The rule for division is that we subtract our exponents. So x to the 19 divided by x to the 3 gives me x to the 16. And y to the 10 divided by y to the negative 2, we do 10 take away negative 2. But when you have two minus signs in a row, that actually ends up being plus. So we do 10 plus 2, which is 12. And this is still to the power of 1/2. Now I'm not going to write this as a big root. I'm going to multiply that 1/2 into all of my exponents, including that hidden 1 on the 25. So I get 25 to the power of 1/2. X to the power of 16 times 1/2 is 16 over 2. And y to the power of 12 times 1/2, which is 12 over 2. Now 25 to the power of 1/2, that's going to be the square root of 25 to the power of 1. X to the 16 divided by 2, 16 divided by 2 is 8. And 12 divided by 2 is going to give me y to the power of 6. Now the square root of 25 is 5 to the power of 1. 5 to the power of 1 is just 5. X to the 8, y to the 6. All right, the next one is a very similar style of question, just slightly different operations. If at any point you would like to try one of these by yourself, you should just pause the video, try it on your own, and then come in and check the answer. So 54 x to the 26 y to the 3 divided by 2 x to the 5 y to the 3 to the power of 4, all to the power of 2/3. So BEDMAS says we start with what's inside our brackets. So I'm going to start by simplifying what's inside our brackets. I have division, and I also have that exponent of 4. So I'm going to start by evaluating, actually applying the rule for my exponent of 4. So I'm going to leave the 54 x to the 26 y to the 3 in the numerator. And in the denominator, I'm going to multiply that power of 4 into all of my exponents, including the secret 1 on that power of 2. So this is going to leave me with 2 to the power of 4, x to the power of 20, and y to the power of 12 in the denominator. And before I do the division, I'm going to work out the 2 to the power of 4. So I have 54 x to the 26, y to the 3, divided by 2 to the power of 4 is 16, x to the 20, y to the 12, all still to the power of 2/3. Now, the division. I'm going to divide 54 divided by 16, which gives me a decimal. I end up with 3.375. I don't want a decimal here, so what I'm going to do is see if I can reduce this as much as I can. I think maybe 8 will go into 54. Nope, not 8. What about 4? Nope. What about 2? All right, so 2 goes into 54, and it would also go into 16. That's going to leave me with 27 over, and 16 divided by 2 is 8. X to the 26 divided by x to the 20. The rule is we subtract the exponents. So 26 take away 20 is 6. And then y to the 3, y to the 12. We're going to do 3 take away 12, which is going to give me negative 9. So y to the negative 9. And then that's still to the power of 2/3. Well, this is where it's about to get a little messy. I'm going to multiply the exponent of 2/3 into my exponents. So the negative 9, the 6, and the invisible negative 1 on that 27 over 8. So I'm going to get 27 over 8 to the power of 2/3 x to the power of 6 times 2/3 is 12 over 3. Negative 9 times 2/3 is negative 18 over 3. Okay, 27 over 8 to the 2/3. That is going to be the cube root of 27 over 8 squared. X to the power of 12 divided by 3 is 4. And negative 18 divided by 3 gives me y to the power of negative 6. Okay, the cube root of 27, 3 cubed is 27, so that's going to be 3. And the cube root of 8, 2 cubed is 8, so 3 over 2 to the 2 times x to the 4. It's a very funny looking x, y to the negative 6. 3 squared is 9. 2 squared is 4, x to the 4, y to the negative 6. And now at the very end, I'm going to take that y to the negative 6. Now a negative exponent, we say, makes a fraction, or it has a flipping over action. So what it's going to do is it's going to take that y, and it's going to flip it down into the denominator with the 4. So we're going to end up with a 9 and an x to the 4 in the numerator, and a 4 y to the 6 in the denominator.